Hello, this is the second session for hematosis, session number 2. We did the illustration of extrinsic pathway and intrinsic pathway for in vitro clotting. All the intrinsic pathways start from tissue thromboplastin. As soon as we have a cut, the tissue thromboplastin, this clotting factors inside the tissue, leaks to the blood, activates factor 7, activate factor 10, factor 10 activate factor 5, and factor 5 activate factor 2, and factor 2 activation turns fibrinogen into fibrin monomer. It still is not clot, this is fibrin monomer, but what turns it into clot, into fibrin polymer, clot, factor 13. So if you look, activated factor 2 اللي هو thrombin, activate factor 13 and activate and turn fibrinogen into fibrin. The other pathway is called intrinsic pathway, is called start with surface contact. We said the as soon as the factor 12 get in contact with the collagen, it's get activated, but it requires Fletchers and Fitzgeralds. These two clotting factors are very important to activate factor 12, but they don't have numbers. 12 activate 11, 11 activate 9, 9 activate 8, but remember the activation of 8 is very important. Require a lipid called platelet phospholipid from the platelet, and require calcium too. Now, this 8 require activate 10 and 5 and 2 and so forth. If you like, this pathway we call intrinsic, and this pathway we call extrinsic. Now, to test the clotting factors in this pathways, the test called PT. To test the clotting factor in this pathway, we call to a PTT. Last week, you saw we did a PT. We took a plasma, and all we had to add is what's missing, tissue thromboplastin and the calcium, and it clotted within 11 seconds, which is a normal range between 11.5 to 12.5. For this pathway, which is called a PTT, partial thromboplastin test, what do we need to add? Everything is there, except the surface contact, we don't have it, the collagen, and we don't have PF3 because it's in the platelet, and we don't have the calcium because it's bound to the anticoagulant. All we have to do then to take the plasma, add the platelet phospholipid and the calcium. Now the surface contact will be provided by the glass tube. The glass tube has a negatively charged, is activate factor 13 along with the Fletcher and Fitzgeralds. This should clot between 25 to 35 seconds. It depends on, this is the normal range for PT. PTT on 11.5 to 12.5. It depends on second, depends on the reference. Now, when we do PTT, if you clot it within this range, mean every factor from here to here is normal. If it doesn't clot within this range, it took like 40, 50 seconds to clot, one of these factors here will be missing. ملاحظين انه this is intrinsic and this is شو extrinsic. What it is in red, it's a common pathway. يعني, in another word, if this is normal, if PTT is normal, mean everything from here to here is normal. If this is normal and this is abnormal, معناتها one from here to here is abnormal. Since we already decided that PTT is normal, معناتها it's not going to be here, it's going to be from here up. It's going to be at least, most likely, factor 7. Not calcium because we added, and not tissue 3 because we added. Now, these are the factors. Factor 1, 2, 3, 4, 5, 7. We said there is no 6, 8, 9, 10, 11, 12, 13, and the two other factors, Fitzgerald and Fletcher's. These factors are grouped into groups, 3 groups. Grouped into 3 groups. Group 1 is called, or fibrinogen group, is made of fibrinogen, factor 5, factor 8, and factor 13. Group 2, or thrombic group, is made of factors 2, of course, 7, 9, and 10. وفي عندنا جروب 3 made of factors 11, 12, Fitzgerald, and Fletcher. What's the main characteristics of group 1? Is consumed during coagulation, not vitamin K dependent, not absorbed by what? By let me see. Not absorbed by barium sulfate. Group 1, not
Group 2.
Group 2, not consumed during coagulation, vitamin K dependent. يعني if we lack vitamin K, we lack these group. يعني we don't clot. Absorbed by barium sulfate. Number 3, not يعني not consumed during coagulation, not vitamin K dependent, not absorbed by barium sulfate. If we are to explain what is consumed during coagulation, remember we have, let's say, we have 2 tubes of blood, one of them sodium citrate, one of them plain tube. اللي هو what? Yes, red. Now after a while, after we draw the blood and we spin, بنلاحظ انه there is some coagulation in the plasma, and here and here. This is called serum, and this is called what? Plasma. The difference between serum and plasma, since here we have anticoagulant, there is no clotting. Yani blood doesn't clot. Yani fibrinogen does not turn into fibrin. Here, it clot. You see a lot of clot here. Fibrinogen turn into fibrin. In this serum here, and in this plasma we have every clotting factors that it is, all here, because they don't clot. In this serum here, since there is a clot, we don't have fibrinogen, we don't have factor 5, we don't have factor 8, we don't have factor 18, because they are consumed in the process of 13. 8, 5, and 1. They are consumed. But, believe it or not, in serum, we still have factor 2, 7, 9, and 10, and these factors. So this is the difference between basically plasma and serum. Serum has less clotting factors available because in serum there is a clotting. There is a clotting. During clotting, all these factors are consumed, disappeared, used by this stat. Now, if you really need this factor or this factor or this factor or this factors, you can use serum because they still have it. But if you need this factor and this every factor, you can use plasma. This is different. Now, vitamin K dependent, which is very important. We have vitamin K in our bodies, so it's usually we never, maybe we do or we do not like vitamin K. Vitamin K is very important for synthesis of these clotting factors. For the synthesis of these clotting factors. If we are vitamin K deficient, we cannot make these factors in a sufficient amount. We tend to bleed. But this group and this group is not affected by the vitamin K. That's why people who are on a blood thinner, they take what's called Coumadin. Coumadin basically vitamin K inhibitor. Coumadin is vitamin K what? Inhibitors. So they don't make enough of these factors. That's why they take longer to clot. They take them. Now, absorbed by barium sulfate. This is gonna come. The importance of this comes later. If we add plasma, we've had all the clotting factor, and we add barium sulfate, and we mix it, and we spin. The barium sulfate goes to the bottom, and this is a plasma. This plasma has all the clotting factors except absorbed. This one, absorbed by barium sulfate. They don't have this, or this, or this, or this. So if you need a plasma without these factors, all you have to do, add some barium sulfate to the plasma, mix it very well. These factors will be absorbed to the barium sulfate, spin it, the supernatant plasma will lack these factors. But, however, group 1 factors and group 2 factors are not affected.
Group 3.
Group 1 and group 3 are not affected by barium sulfate. If we go to the sample, this stuff is bad. 13. The sample required أول شيء sodium citrate. We just said that, blue top. ثاني شيء, in order for the blood, as we said in phlebotomy, remember phlebotomy? When we draw blood, the plasma don't need to be contaminated with what? Tissue thromboplastin has to be drawn second or third tube, not the first tube. ثالث شيء, be done, the test should be done within 4 hours after the blood is drawn. However, the blood has to be separated within 1 hour, and the plasma is placed on ice until it is tested. So why it has to be placed on ice? Because some factors are labiles. As soon as it's drawn, they start disintegrating, they start lose their activities, like factor 5. Factor 5 is a very labile, it loses activity. So we have to do it immediately. You know, as soon as we draw the blood, within 1 hour, we have to separate plasma from the blood, and we put the plasma on ice until it is tested. The one thing we have to do, we have to make sure hemolyzed. You know what hemolyzed? Ecteric and lipemic blood or plasma. Hemolyzed is when you see plasma is red, a lot of broken RBC. This tends to shorten the PT and PT. If it's hemolyzed, we refuse it. Ecteric mean the plasma has high amount of bilirubin. Has amount of what? Bilirubin. Lipemic has high amount of fat, especially triglycerides. You can see it like a very cloudy, or sometimes you see it white. Here the color is like yellow green. These should be refused because these could not be tested in any automated machine, because the light cannot go through. But this should be tested immediately refused. All of them should be refused because we all use automated testing. So hemolyzed affect the result or interfere with the result. Ecteric and lipemic interfere with the result. Today, as we said, we are gonna do the PTT. Do you know? PTT test. PTT, everything is there in the plasma. We're gonna take sodium citrate plasma, except PF3, because this is not a clotting factor. This is not a protein. This is a fat secreted from the platelet, and since we don't have platelet in the serum, so we have to add the PF3 phospholipid, platelet phospholipid. We have to add calcium because the calcium is bound to sodium citrate, and that'll be it. This and this, and it should clot. Now the surface contact is provided by the glass wall, the glass tube walls, which is negatively charged. Now we should, if it's normal, should be clot between 25 to 35. Some references it depends on the reagent, between 26 to 40. It depends on the reference and the reagent you use. So most references are for PT for around 11.5 to 12.5, for PTT to 25 to 35 seconds. Now the next we are gonna go and do the PTT test manual. Later on, next week, we're gonna do any PT test using automated machine. But we have to at least see the clot. See, there is really actual clot. If we add the tech plasma and we add tissue thromboplastin and we add calcium, we are gonna get clot, and we are gonna get it between 25 to 35 seconds using our eyesight. All right? Thanks.